Hey guys, today we are going to decompose partial fractions, which sounds disgusting, but really it's not too bad. It just takes a little bit of practice. So first of all, to kind of get into the idea of what decomposing means, let's subtract these two fractions. So we know that when we need to subtract fractions, we need to have common denominators, and we can always get a common denominator by multiplying by the other denominator. So I'm going to multiply that first fraction by x plus 4 over x plus 4, and I'm going to multiply that second fraction by x plus 1 over x plus 1. So we know we have a common denominator of x plus 4 times x plus 1. I'm going to go ahead and distribute that 8 out over here and get 8x plus 32 minus. We have the same denominator over here of x plus 4 times x plus 1. Then we'll distribute out the 5, and we'll get 5x plus 5 in our numerator. Now remember, we're subtracting this entire fraction over here, so that negative needs to go to both our 5x and our 5. So this is really 8x plus 32 minus 5x minus 5 when we put those together in our numerator. And then we have that common denominator of x plus 4, x plus 1. Then we'll go ahead and combine like terms. 8x minus 5x is 3x. 32 minus 5 is 27. And that's over x plus 4, x plus 1. Now, why the heck did we do that? Well, here's what I wanted to tell you. Partial fractions, they're going to go ahead and take that 3x plus 27 over x plus 4 times x plus 1, and they're going to help us get back to 8x, or 8 over x plus 1 plus negative 5 over x plus 4. So partial fraction decomposition helps us go backwards. The reason why we would want to do partial fraction decomposition, why we would want to simplify those fractions, is that finding the derivative of those other two is going to be a whole lot easier than finding the derivative of that first one. So in calculus, it's going to make life a whole heck of a lot easier. So first of all, partial fraction decomposition can only be done when the denominator's power is higher than the numerator's power. So the way that we solve that issue, if it's not, is we're going to do polynomial long division. We'll end up with a polynomial and then we'll have some sort of equation that's its remainder over what we were dividing by the first time. Cool, so here is how we decompose partial fractions. So the first thing we want to do is factor the denominator. And now this table, I'm actually going to move my face out of the way for a minute. Okay, it won't let me. I'll just be like right down here. Okay, cool. Copy this table down. It's important. So we're going to use this table to determine which terms we're going to have in our decomposition. So if you have something that's just plain old linear, you're going to put a letter on top of him and move on with your life. If you have something that's linear to a power, a repeated power, you're going to start with that linear guy to the first power, then to the second power, then to the third power, all the way up to whatever power that you're on. So if you had x to the fourth, you would have x squared, x cubed, x to the fourth. And each of those would have an a, b, and a c on top. Now, if you have something that's quadratic and it's prime, and what I mean by prime is mean that it's not factorable. So if you have something that's quadratic, that's not factorable, you're going to have ax plus b in the numerator for that guy. Okay, so what you're going to do next is write out that decomposition that we decided our terms for up above. Then we're going to determine our lowest common denominator and write an equation. Once we write that equation, we're going to create and solve a system of equations using matrices. And then once we find out what A, B, C, D, whatever our letters are equal to, we can go ahead and write out our fractions. Okay, let's look at the first one. Hey guys, so let's try this. So, we want to factor the denominator first. So we want to find two numbers that multiply to negative 18 and add to positive 3. So that will be positive 6 and negative 3. So we still have that 8x minus 42 in our numerator. But we know that x squared plus 3x minus 18 is going to factor down into x plus 6, x minus 3. Our next step says to determine our terms. We determine our terms with our denominator. So one of our fractions is going to have that x plus 6 in the denominator. Our other fraction is going to have x minus 3 in the denominator. Now let's look back up. X plus 6 and x plus 3, those are both linear, right? So if we look back up here, whenever we have linear, we're just going to put a letter up on top. So I'm going to put an A on top of x plus 6, and I'm going to put a B on top of x minus 3. Now I know I want these two fractions to add to what I had just a minute ago, 8x minus 42 over x plus 6 times x minus 3. Now we know to be able to add fractions together, we need a common denominator. So I need to multiply my a fraction by x minus 3 over x minus 3. And I need to multiply my b fraction with x plus 6 over x plus 6. So that way everything has a common denominator. So that was my next step, get a common denominator. Now we're going to add our fractions together. So first of all, let's distribute that a on out. I have ax minus 3a, that's over x minus 3, x plus 6, plus. Then we'll distribute out our b. We have bx plus 6b over, and then our common denominator was x minus 3, x plus 6. And then we want that to be equal to 8x minus 42 over x minus 3, x plus 6. Although it feels kind of counterintuitive, once all of your denominators are the same, you're just going to ignore it. So we're going to make an equation from our numerator. So right now we know that ax minus 3a plus bx plus 6b equals 8x minus 42. Now what I'm going to do is I'm going to group my like terms together. So I'm going to make an equation out of my x's. I have ax plus bx equals 8x. Then I'll make an equation out of my plain old numbers. I have a negative 3a plus a 6b equals that negative 42. So we regrouped We created our equations. Now we want to create a system of equations. This is my system right here. So what we want to use is that augmented matrix that we did last time. So let's look at our coefficients. So we're going to think about this guy as just A plus B equals 8. And we are going to think of this guy as negative 3A plus 6B equals negative 42. What we want to do is find out what A and B are, so that way we can pop them back in from this step before. Cool. So we've got those two equations. Now we're going to make an augmented matrix out of them. So that first row, A plus B equals 8. Coefficient on A is 1. Coefficient on B is 1. And then my plain old number is 8. For negative 3A plus 6B equals negative 42, my coefficient on A is negative 3, my coefficient on B is 6, and my plain old number is negative 42. So now that we have a matrix, we're going to go ahead and use our graphing calculator to solve the system. So I'm going to click New Matrix. This is 2 rows and 3 columns. 1, 8, negative 3, 6, negative 42. Press Enter. I'm going to click on Reduced Row Echelon Form right behind my head. There it is. Reduced Row Echelon Form of A. Enter. All right. So we're ending up with 10, negative 2. My face back. All right. So over here, when we put it into reduced row echelon form, this is the matrix that we got. So remember that this first column was A, second column was B, and then my last column was plain old numbers. So really my answer was A is equal to 10 and B is equal to negative 2. Well, remember, we started out with this decomposition of, here I'm going to write it separately real quick, that A over x plus 6 plus B over x minus 3. Well, now we know what A and B are, right? A is supposed to be 10 and B is supposed to be negative 2. So now we'll just write our values in for A and B, and we're done. So let's see, 10 goes in for A, so we have 10 over x plus 6. And we know negative 2 goes in for B, so we're going to have plus negative 2 over x minus 3, or minus 2 over x minus 3. Either one is fine. Now, 10 needs to be on top of x plus 6, and negative 2 needs to be on top of x minus 3, or else it's not right. Okay, let's try another one. So the first thing we want to do is factor our denominator. So remember, we need to make the rainbow, so we need to take 2 times negative 4, and we'll get negative 8. And then we want our numbers to add to 7. So that'll be positive 8 and negative 1. Let's split the middle term. 2x squared plus 8x minus 1x minus 4. Factor out a 2x. And we're left with x plus 4. So we'll have to factor out a negative 1 to get x plus 4 right here. And then we'll end up with 2x minus 1, x plus 4 for my denominator. So we have 9 minus 9x over 2x minus 1, x plus 4. All right, so we factored our denominators. Now we want to determine our terms. So one of our denominators is going to be 2x minus 1. My other denominator is going to be x plus 4. 2x minus 1 is linear since it's a plain old x. X plus 4 is also linear since it's a plain old x. So if we look back up here, since both of them are linear, we're going to be using this guy right here. So we're just going to put letters on top. So we'll put an a on top of 2x minus 1, and we'll put a b on top of x plus 4. And we know in the end we want this to be equal to 9 minus 9x over 2x minus 1 times x plus 4. The next thing I'm supposed to do is get a common denominator. So I'm going to get a common denominator by multiplying by the denominator of the other fraction. So I'm going to multiply a by x plus 4 over x plus 4. And we're going to multiply my b fraction by 2x minus 1 over 2x minus 1. So once again, once all of my denominators are the same, I'm just going to go ahead and ignore them. But I am going to distribute out my a, so I'll get ax plus 4a. Then we'll distribute out my b. We'll get 2bx minus b. And we want that to be equal to 9 minus 9x. So we made our equation from our numerator. Now we're going to regroup all of our x stuff. So I've got ax, 2bx, and negative 9x. We're going to make an equation out of him. So we have ax plus 2bx equals negative 9x. So then we'll get rid of all of those x's. So we'll really think of this equation as a plus 2b equals negative 9. Then we'll make an equation out of just our numbers. So we have a 4a, a negative 1b, and a 9. So we have a 4a minus 1b equals 9. So let's make an augmented matrix out of this. So in that first equation, a plus 2b equals negative 9, my coefficient on a is 1, my coefficient on b is 2, and my plain old number is negative 9. In 4a minus 1b equals 9, my coefficient on a is 4, my coefficient on b is negative 1, and my plain old number is 9. So then we'll use our graphing calculator. Clear all, new matrix. And this is a 2 by 3. 1, 2, negative 9, 4, negative 1. Oopsies, forgot the 1 on there. Cool. And then positive 9. Press enter. Reduced row echelon form of matrix A. And we end up with 1 and negative 5. 1, 0, 0, 1, 1, negative 5. All right. So that's the matrix we ended up with when we put it into reduced row echelon form. So we found out that A is equal to 1 and B is equal to negative 5. Sorry, stuff just is not working for me today. So first of all, we know that A is equal to 1 and B is equal to -5. So we'll go back up here, and we had this guy earlier where we had A over 2x minus 1 plus B over x plus 4. So we found out that A was 1, so he'll go over that 2x minus 1. And we found out that B was -5, so he will go over our x plus 4. My face is in the way. There we go. All right, so you can put that as plus -5, minus 5 over x plus 4, that's fine too, as long as the 1 is on top of the 2x minus 1 and the -5 is on top of the x plus 4. Okay, let's look at this next one. So we don't need to factor this time, but we do need to determine our terms. So remember, they all come from our denominator. One of our terms is going to have an x minus 1 plus. And then right here, since we have a power on that, we have a repeated power. Now let's remind ourselves what that looks like. So when we have something to a power in our denominator, when we're trying to figure out our terms, we're going to take that guy to the first power, then to the second power, then to the third power, all the way up until we reach the power that we're on. So I have x minus 2 squared, so that means I'm going to start with x minus 2 to the first, and then x minus 2 squared. Since my exponent is 2, I stop at 2. If it were 3, I would go up to 3. If it were 4, I would go up to 4. Okay. Now, on number 1, or in the first fraction and in the second fraction, those are both linear, right? So we need to have an A and a B. Now, on this last guy, he's technically quadratic, right? Since he's squared. But remember, on a repeated power, we're supposed just to go A, B, C, D, and not worry about the power. So this guy's just going to have a C on top. Then we want this to be equal to 4x squared over x minus 1 times x minus 2 squared. So now we need to be able to get a common denominator. So we're going to find a common denominator so on that first fraction we have x minus 1. So he needs an x minus 2 squared and an x minus 2 squared to have the same denominator. B needs an x minus 1, and he also needs an x minus 2. C already has my x minus 2 squared, so all he needs as well is my x minus 1. Okay. So we've got A times all of x minus 2 squared over x minus 1, x minus 2 squared, plus. We're going to have to take B times all of x minus 1, x minus 2, over x minus 1, x minus 2 squared, plus. And then C will be multiplied times all of x minus 1 over x minus 1, x minus 2 squared. And that will be equal to 4x squared, x minus 1, x minus 2 squared. So now that I have all of the same denominator, I'm going to ignore it. And then A. Remember to actually multiply out x minus 2 times x minus 2. So that way you'll get x squared minus 4x plus 4. then you're going to have to take b times, then we'll distribute out x minus 1 times x minus 2. It's going to be x squared minus 3x plus 2. And then c doesn't have any simplifying that needs to happen. So then I'm going to go ahead and distribute out my a, b, and my c. So I have ax squared minus 4ax plus 4a plus bx squared minus 3bx plus 2b plus cx minus c equals 4x squared. So now we'll make an equation out of my x squared stuff. All right, so I have an ax squared and I have a bx squared. I don't have a cx squared, so I'm going to put a 0 in there. And then for my plain old numbers, I know that I have that should be equal to 4x squared. Now we'll look at just the plain old x's. So I have negative 4ax and negative 3bx, and we have a positive cx. Now I don't have any x's over there on my right side with my 4x squared, so that will be equal to 0. Then we'll have our plain old numbers. So I have 4a plus 2b, and then we've got a minus c. I don't have any plain old numbers over there on the right with my 4x squared, so that will be equal to 0. So now we have our equations. So we'll put those into an augmented matrix. My coefficient on A, this is my x squared row. My coefficient on A is 1. My coefficient on B is 1. I don't have a C, so that's a 0 right there. And then my 4 is going to go there at the end. For my x row, my coefficient on A was 4. My coefficient on B was negative 3. My coefficient on C was 1, and we knew that was equal to 0. In my just plain old numbers equation, my coefficient on A was 4. My coefficient on B was 2. My coefficient on C is negative 1, and that's equal to 0. So now we'll go to Desmos and put that in. So let's go ahead and clear him from last time. I'm going to click New Matrix, and this is a 3 by 4 matrix. Oopsies. 1, 1, 0, 4, negative 4, negative 3, 1, 0, 4, 2, oopsies, negative 1, lost the 2, and then 0. Let me double check. Yep, no mistakes, cool. Enter. So then we're going to reduced row echelon form this guy. We're ending up with 4, 0, 16. So remember, that means that A is equal to 4, B is equal to 0, and C is equal to 16. So back up on top, earlier, remember we started with A over x minus 1 plus B over x minus 2 plus C over x minus 2 squared. That's what we had in this step right here. So all we need to do is put in A, B, and C. A we know is 4, so that's going to go on top of x minus 1. B is 0. So 0 divided by x minus 2, that's just 0. So we don't need to worry about that term. plus, and then C was 16 over x minus 2 squared. Okay, let's look at the next one. That's all of them. Cool. All right. I'll see you a little bit later.